They weren't pilots, or scientists, or engineers. They fixed bicycles in Ohio. But in 4 years, they did what centuries of thinkers, kings, and inventors couldn't. They flew. Not by luck, not by accident, by method, by testing, by raw determination. From a paper toy to a flying machine that changed the world. This is the story of the Wright brothers, the men who proved flight wasn't magic, it was math. Wilbur Wright was born near Millville, Indiana in 1867, while his younger brother Orville entered the world in Dayton, Ohio in 1871. Their paths to aviation began in childhood when their father brought home a simple toy in 1878. This small device, made of paper, bamboo, and cork with a rubber band motor, captivated both boys. The helicopter-like toy was based on an invention by Alphonse Pénaud, and the brothers later credited this moment as the spark that ignited their lifelong fascination with flight. The Wright family shaped these future aviation pioneers in ways that would prove crucial to their success. Their mother, Sarah, possessed remarkable mechanical skills, having learned from her carriage maker father. She built her own appliances and created toys for her children, regularly offering technical advice to her sons as they developed their own mechanical interests. This early exposure to hands-on problem-solving and mechanical thinking established patterns that would serve them throughout their lives. Before they ever thought about airplanes, the Wright brothers demonstrated their entrepreneurial spirit and technical abilities through various business ventures. In 1889, Orville started a printing business while still in high school. The brothers soon launched a newspaper called the West Side News, with Wilbur serving as editor. When the newspaper business failed to generate profits, they pivoted to commercial printing. Among their notable projects was the Tatler, a newspaper they printed for the African-American community in Dayton. The bicycle craze of the 1890s provided the brothers with their most successful business opportunity. In 1893, they began selling and repairing bicycles. 2 years later, they started manufacturing their own models, the St. Clair and the Van Cleve. Their bicycle business proved profitable and allowed them to develop crucial skills in mechanical design and manufacturing. The brothers designed custom features for their bicycles, including oil-retaining wheel hubs and coaster brakes, innovations that remain standard on modern bicycles today. By 1896, the Wright brothers had turned their attention to what they called the flying problem. This was not a casual interest. For centuries, humans had dreamed of flight, watching birds with envy, and attempting various contraptions to achieve sustained, controlled flight. Hot air balloons could lift humans into the sky, but they floated at the mercy of wind currents. Gliders could carry a person aloft, but only briefly and without power. The brothers faced 3 fundamental challenges that every aspiring aviator before them had encountered. What no one had achieved was controlled, sustained, powered flight. First, they needed to generate enough lift to overcome gravity and get their machine airborne. Second, they required a power source capable of sustaining flight. Third, and most critically, they had to solve the problem of control. How could a pilot maintain balance and steer an aircraft through 3-dimensional space? Previous experimenters had focused primarily on the first 2 challenges. They built larger wings to generate more lift and more powerful engines to provide thrust. The Wright brothers took a radically different approach. They recognized that control was the key to solving the flying problem. This insight would prove to be their greatest breakthrough. In 1899, Wilbur devised an aerodynamic control system and built a kite to test his theories. This marked the beginning of their systematic approach to aviation research. Unlike other experimenters who relied on trial and error or copied bird flight patterns, the Wright brothers applied scientific methodology to every aspect of their work. Their research methodology included 3 crucial components. First, they studied existing data on flight and quickly discovered that much of it was inaccurate or incomplete. Second, they conducted their own original research using a wind tunnel they built in their bicycle shop. Third, they tested their theories through actual flight experiments with gliders of increasing size and sophistication. Between 1900 and 1902, the Wright brothers traveled to Kitty Hawk, North Carolina, to conduct glider experiments. They chose this location for its consistent winds, soft sand landing surfaces, and relative isolation. During these 3 seasons of testing, they made nearly 2,000 glider flights, systematically refining their understanding of lift, control, and stability. The 1902 glider represented their most significant breakthrough in control technology. This aircraft featured the world's first 3-axis control system, allowing the pilot to control pitch, roll, and yaw movements. The forward elevator controlled pitch by moving the nose up and down. Wing warping provided roll control by twisting the wingtips to different angles. A rear rudder controlled yaw by steering the aircraft left and right. How did wing warping actually work? The Wright brothers had observed that birds twisted their wingtips to maintain balance and change direction. They replicated this natural phenomenon through an ingenious mechanical system. The pilot lay on the lower wing and moved his hips left or right in a specially designed cradle. This movement activated cables that twisted the outer portions of the wings to different angles. When the pilot shifted his weight to the right, cables pulled the right wingtip down and the left wingtip up. This created unequal lift forces on the 2 wings, causing the aircraft to roll to the right. The brothers connected the wing warping system to the rudder control, so both movements occurred simultaneously. This coupling proved essential for making coordinated turns. The technical elegance of this system cannot be overstated. With simple mechanical controls, a pilot could manage all 3 axes of aircraft movement. Modern aircraft still use this same basic principle, though ailerons have replaced wing warping for roll control. The Wright brothers had solved the control problem that had stymied aviation pioneers for centuries. With control mastered, the brothers turned to the challenge of powered flight. They calculated that they needed an engine producing at least 8 horsepower, while weighing no more than 200 pounds. No suitable engine existed in the automotive market, so they decided to build their own. Working with their shop mechanician Charlie Taylor, the Wright brothers designed and constructed a revolutionary aircraft engine. Taylor later described the informal design process. "We didn't make any drawings. One of us would sketch out the part we were talking about on a piece of scratch paper, and I'd spike the sketch over my bench." The engine featured several innovative design elements. The engine block was cast from an aluminum alloy containing 92% aluminum and 8% copper. This provided strength while minimizing weight. The crankshaft was machined from a solid block of steel, using only a lathe and drill press. Taylor traced the outline on the steel slab, drilled holes to remove excess material, then shaped and smoothed the part on the lathe. The completed engine weighed 180 pounds and initially produced nearly 16 horsepower, though this dropped to 12 horsepower as the engine heated up during operation. The simple fuel system consisted of a small tank suspended from the wing that fed gasoline to the engine through gravity. The engine had no fuel pump, carburetor, spark plugs, or throttle, yet it produced well above their minimum power requirement. Creating an efficient propeller proved as challenging as building the engine. The Wright brothers approached propeller design with the same scientific rigor they applied to wing design. They conceptualized the propeller as a rotating wing moving through the air in a helical path. Using data from their wind tunnel experiments, they calculated the optimal blade shape for converting engine power into thrust. The brothers handcrafted their propellers from laminated spruce using draw knives and hatchets. They covered the tips with linen fabric and sealed them with aluminum powder suspended in varnish. The 1903 Flyer used 2 propellers, each measuring over 8 feet in diameter. These propellers achieved 66% efficiency, providing enough thrust to achieve flight at Kitty Hawk. Later, propeller designs incorporated the brothers' growing understanding of aerodynamics. Their bent-end propellers, first used in 1905, featured curved tips that maintained proper pitch angles under the stress of rotation. These propellers generated 210 pounds of thrust, compared to the 120 to 130 pounds produced by their original 1903 designs. December 17, 1903 dawned cold and windy at Kill Devil Hills near Kitty Hawk. After months of preparation and setbacks, the Wright brothers were ready to attempt powered flight. They had won a coin toss to determine who would fly first, but Wilbur's initial attempt on December 14th had ended in a brief stall. On this historic morning, Orville took the controls while Wilbur ran alongside the Flyer to help guide it down the launching rail. At 10:35 a.m., the aircraft lifted off and flew for 12 seconds, covering 120 feet. The brothers made 3 more flights that day, with Wilbur achieving the longest flight of 852 feet. in 59 seconds. These 4 flights represented more than just the first powered airplane flights. They demonstrated controlled, sustained flight by a heavier-than-air machine carrying a human pilot. Each flight was witnessed and documented, providing irrefutable proof that the age of aviation had begun. The Wright Flyer itself was a marvel of engineering efficiency. The aircraft had a wingspan of 40 feet and weighed 605 pounds. Its wooden frame used spruce for straight members and ash for curved sections. The wings were covered with finely woven cotton cloth, sealed with canvas paint, similar to what local sailors used on their sails. Bicycle spoke wire provided structural rigging, connecting the brothers' aviation work to their bicycle manufacturing experience. Success at Kitty Hawk was just the beginning. The Wright brothers spent 1904 and 1905 developing practical aircraft near Dayton, Ohio. They built improved versions of their flyer and established the world's first test flight facilities at what would later become Wright-Patterson Air Force Base. The 1905 Wright Flyer 3 represented their first truly practical airplane. This aircraft could remain aloft for extended periods and perform complex maneuvers including circles and figure eights. On October 5, 1905, Wilbur flew for 39 minutes and 23 seconds, covering 24.5 miles. This flight conclusively demonstrated that the Wright brothers had created a viable flying machine. Despite their success, the brothers faced skepticism from the press and public. Many newspapers dismissed their claims as hoaxes or exaggerations. The scientific community remained largely unaware of their achievements. This skepticism ended dramatically in 1908, when Wilbur demonstrated their aircraft in Europe. Wilbur's public demonstrations in France began on August 8, 1908, at the Hunaudière horse racing track near Le Mans. French aviation enthusiasts had been particularly dismissive of American claims about flight, calling Wilbur a bluffeur or fraud. His first flight lasted only 1 minute and 45 seconds, but his effortless banking turns amazed onlookers, including pioneering French aviator Louis Blériot. Over the following days, Wilbur performed increasingly complex maneuvers that demonstrated the superiority of Wright aircraft over European designs. He flew figure eights, maintained precise control in windy conditions, and carried passengers on extended flights. The French public flocked to watch these demonstrations, with thousands gathering at the airfield daily. The European success established the Wright brothers as international celebrities and validated their technical achievements. Former critics issued public apologies and effusive praise. The brothers established flying schools in France and Italy, training the first generation of European pilots in Wright aircraft control techniques. Success brought new challenges in the form of patent disputes that would consume much of the brothers' energy for years. In 1906, they received U.S. patent 821,393 for their 3-axis control system. Rather than claiming invention of the airplane itself, this patent covered their method of controlling aircraft through coordinated movements of elevator, rudder, and wing warping mechanisms. The Wright Company, formed in 1909 with the brothers selling their patent rights for $100,000 plus stock and royalties, aggressively pursued patent infringement cases. They sued domestic and foreign aviators and manufacturers, most notably aviation pioneer Glenn Curtiss. In 1910, they won their initial lawsuit when federal judge John Hazel ruled in their favor. The patent wars stifled American aviation development for years. Many historians believe this legal warfare prevented the United States from maintaining its early lead in aviation technology. The situation was finally resolved in 1917, when the government established a patent pool system that allowed aircraft manufacturers to share technology for World War I production. The Wright brothers' dedication to aviation came with significant personal costs. Neither brother ever married, devoting their lives entirely to their work and family. They shared an unusual bond, thinking and working as a unified team while maintaining distinct personalities and perspectives. The brothers flew together only once during their entire partnership. On May 25, 1910, they took a 6-minute flight with Orville as pilot and Wilbur as passenger. On the same day, Orville took their 82-year-old father, Milton, on a 7-minute flight, fulfilling a promise to give the elder Wright an aerial view of their hometown. Tragedy struck in 1912 when Wilbur died of typhoid fever at age 45. Orville continued their work alone, eventually selling his interest in the Wright Company in 1915. He lived until 1948, long enough to witness the transformation of aviation from experimental curiosity to global transportation system. Every airplane that flies today incorporates fundamental principles pioneered by the Wright brothers. Three-axis control remains the standard method for piloting aircraft, though modern systems use ailerons instead of wing warping for roll control. The brothers' systematic approach to aerodynamic research established methodologies still used in aircraft design. Their wind tunnel research proved particularly influential. The data they collected on wing shapes and airflow patterns provided the foundation for subsequent aerodynamic development. Modern wind tunnels like the Wright brothers' Memorial Wind Tunnel at MIT continue this research tradition, serving academic and commercial aviation needs. The propeller theory developed by the Wright brothers remained the standard for aviation until the jet age. Even today, propeller aircraft rely on design principles the brothers established in their Dayton workshop. Their understanding of propeller efficiency and thrust generation influenced not only aviation, but marine propulsion and wind turbine design. More than a century after Kitty Hawk, aviation continues evolving in directions the Wright brothers could never have imagined. Modern aircraft carry hundreds of passengers across oceans at speeds approaching the speed of sound. Spacecraft regularly travel to the International Space Station, carrying pieces of the original 1903 flyer as tributes to the brothers' achievement. Current aviation research explores concepts that echo Wright brothers' innovations. Morphing wing technology investigates ways to change wing shape during flight, similar to the wing warping system that gave the brothers their crucial control advantage. Engineers study bird flight patterns, just as Wilbur and Orville did over a century ago, seeking new insights into efficient flight. Electric and hybrid propulsion systems promise to revolutionize aviation, just as the Wright engine did in 1903. Autonomous flight systems may eventually eliminate the need for human pilots, though they will still rely on the three-axis control principles the brothers established. Urban air mobility concepts envision personal flying vehicles that would fulfill humanity's ancient dream of individual flight. The Wright brothers gave humanity more than the ability to fly. They demonstrated that systematic research, persistent experimentation, and methodical problem-solving could overcome seemingly impossible challenges. Two men working in a bicycle shop proved that breakthrough innovations do not require vast resources or formal credentials, but rather deep understanding, careful observation, and unwavering determination. Their legacy extends far beyond aviation. The Wright brothers' approach to innovation influenced fields from automotive engineering to space exploration. Their wind tunnel methodology advanced aerodynamic research across multiple industries. Their patent work, despite its controversial aspects, established important precedents for protecting intellectual property in emerging technologies. Today, as we stand on the threshold of new transportation revolutions, including autonomous vehicles, hyperloop systems, and commercial spaceflight, we can draw inspiration from the Wright brothers' example. They faced the unknown with scientific rigor, embraced failure as a learning opportunity, and never lost sight of their ultimate goal. In just 4 years, they transformed humanity's relationship with the sky, proving that even the most audacious dreams can take flight when pursued with passion, precision, and perseverance.